Okay, if you've been doing that homework that we agreed to, I've got a recording of that. So far, you should have seen that a simplex is a region, so a little coloured in area on a graph, not just lines. And we colour that region in because we have multiple constraints, multiple lines enclosing a particular shape on a Cartesian plane. Now currently, all the possible solutions are equally as good as each other. However, what we're doing, and the reason why this topic, if you look in your book, it talks about linear optimization. If I'm optimizing something, am I doing the worst possible option or am I doing the best possible option? Best. So in the real world, we often want the best or the optimal solution that meets a particular objective within the constraints. So all you've done so far is setting up constraints. You haven't found the best option yet. That's what we're doing now. At our level of maths, the optimal solution is either going to be a maximum or a minimum. We only need to deal with those two. The objective in this topic is represented by another linear expression. So another equation in the scenario. This linear expression is known as the objective function, and we write it in terms of x and y. And linear programming is any technique used to find the optimal value for an objective function within a set of constraints. The technique that we're using is called the Simplex Algorithm. So this little note in red, no one believes me. No one believes me until stuff happens and then you realize that I was right. I'm mostly right, okay? The rest of this whole topic is just this lesson, over and over again with slight variations. So what can I say about this? What do the kids say? Get good. Get fast at this. Because this is a time-consuming process. This won't just take me 10 minutes because it's going to be slow because I'm teaching it to you. You draw a bunch of lines, you colour in, you do a bunch of tables. The reason why you do those exercises leading up to this is, did you practice drawing lines? So you should be fast at that. If you did the homework in week 11, did you practice enclosing a region and colouring it in? Good. So yeah, what you're doing now, the Simplex algorithm, uses all of that, all in one go. So what I'd like you to do, please, can you get this information down? Because that boils everything down to what you need to do. Maybe you sit over there so you can actually see it. There's a little table over there. Yeah. So what is the Simplex algorithm? It's a set of steps for finding the optimal solution for a scenario that involves two variables. In general maths, we stop at two variables, x and y. The key point of the Simplex algorithm is the optimal solution always occurs at a vertex, at a corner. So if you did the homework for week 11, there was a couple of questions that said, what are all the optimal solutions? And one of our friends here that came to the holiday shoot, you're like, do you actually mean that I have to count every dot within the coloured point? Yes. But that leads into this, because what have I just said? The optimal solution always occurs at a vertex of the simplex. So that's one of the corners. So if you did that question, and you would have been a bit, upset that you had to count all the dots, that's good. Use that pain, use that anger to realize that when we do Simplex algorithm, you only have to check the corners. You don't have to do every point in the coloured in area. So what are the steps? Decide on two variables in the scenario, x and y. Step 2, decide what the objective function is. You'll read that from the question. It's what you're asked to minimize or maximize. Construct the constraints and write them in general form. I recommend a table. Sketch the simplex, colour it in, label the axes. Those are all worth marks. Label the vertices, the corners. And really, the only new thing that you're adding to what you've been doing in the previous exercises is step 5, making this little table where you check the vertex and the objective function in there. You can see what that's about when we do an example. And you find the optimal solution. Can you get that down? I'll give you like 5 minutes. And again, you won't believe me, but if you do get fast at it, these questions actually can be kind of fun. Because when it all sits into place and you get the answer, you see the question, that achievement is nice. How's methods going?
Yeah, good. Holidays have stuffed up my schedules.
Alright.
And my test schedules are way off.
Yeah.
Because I joined late, but it's alright.
If you have coloured pencils, please get them out. You may use coloured pencils in the test for these questions. Keep it down, this recording. One thing you'll also notice is that there's not many questions on the timeline. You only have to do what does have to mean? I'm asking you to do certain questions on the timeline, but if you want extra practice, do the ones that it didn't ask for. There's not many of them. We're talking about 1, 3. You could do a little diversion and do 2 as well. Three minutes and we'll do the example. Remember, this video will be uploaded, so if you missed anything. One more minute. $30. I've only got 6 more of your DIs to mark. You should know it either. You would know it, but I got sick over the right at the end. Okay. And no, I should have brownie points for marking your tests. Okay. It's not going to be 3 months, like others that shall not be named.
Unnamed.
And then we don't know who we're talking about. Oh, I don't know. I'm not friends with anyone. All right. Let's try these 6 steps. All right, two supplements, Power Boost and Super Health, are used by Josiah Langdon James. Power Boost contains 30 grams of carbs, 30 grams of protein, 100 grams of vitamins. Super Health contains 10 grams of carbs, 30 grams of protein, 200 grams of vitamins. Each week, Josiah must consume at least, do you reckon at least is important? Yes. Because what does that mean? Less than or equal to or greater than or equal to? Greater than or equal to. Let's highlight what we think is important. This is probably important. This. Numbers are important, mate. The name Power Boost and Super Health, only important enough that I need to know what X and Y are, but they probably don't come into the question. Does it matter that it's Josiah? No. At least is important. At least 1,400 grams of vitamins, but no more than 330 grams of protein. If we say no more, what sign is that? Less than or equal to or greater than or equal to? Less than or equal to. If you have too much protein, you get these weird lumps in your eye and stuff. It's better. Right? Tins of Power Boost cost $5 each. Tins of Super Health cost $3 each. You reckon the prices are important? Yes. Money's a bit tight for Josiah, so he wants to satisfy his dietary requirements while minimizing the costs. In Year 12 General Maths, what optimization did I say you would do? Either maximizing or? Minimizing. Do you reckon the fact that it said minimizing is important? Because that's my objective. This is going to decide what my objective function is. A, find the optimal combination of tins of Power Boost and Super Health that Josiah should buy weekly and state how much this would actually cost. And B, how much carbs, protein and vitamins does he get with the optimal combination. This is bringing all together everything that you've done up until this point from after your shares test. We haven't even done any maths yet. I'm just highlighting what's important. So if I let X be the number of tins of Power Boost and Y be the number of tins of Super Health, you do not need to, but I recommend that you use a table to construct your constraints because I asked you to do exercise 2B. You don't need to use a table, but it organizes it nicely. Variable X is the number of tins of Power Boost. What are the constraints here? What is limited? What are we saying that we're not allowed to have too much, or we have to have at least?
We have to have at least.
Yep, what? Starts with a C?
Carbs.
Good, that's a constraint. So let's put a little title here for carbs. What's another constraint? What's something that I have resources for that I'm limited with?
400 grams of vitamins.
Just tell me what the thing is. Do it in the order. Carbs. Protein. And what was the last one? You said it already. What was the last thing? Vitamins. I need to sit down for this, mate. Writing's going bad. All right, so if you were to go up to the information here, how much carbs does a Power Boost tin serving or whatever contain? How many?
30.
What does it say? 30. So that's the constraint for carbs for Power Boost. And what does Super Health contain in terms of carbs? 10. And what did you say the limit or the constraint for carbs was? Each week Josiah must consume what? At least 170 grams of carbs. So in the carbs thing, at least, what is that? You told me what? Less than or equal to or greater than or equal to? Greater than or equal to 170. Can you see why using the table is useful? Because that's my constraint right there. Let's do protein. I'm going to talk less. What would the protein table be? What would I write into the protein constraint table?
30.
And
330. Oh.
Yes, but we need... Yes, good. 30. 30. Why does it say less than? Because no more than 330. So it's going to be less than or equal to 330. Someone else for the vitamins. What numbers do I write for vitamins?
Greater than or equal to 1,400.
Yeah, but let's talk about the constraints there. Greater than or equal to 1,400. Yes, I'm cool with that, but we need to fill in the rest of that table.
100 and 200.
Good. 100 and 200. There's one aspect of all that information I haven't put in. Have I chucked in dollars yet into the table? That's not a constraint though. That's what I'm trying to minimize. But we could chuck the dollars in here. What's the cost of a power boost? And what's the cost of a super health? 3. So 5 and 3. So hopefully you see here why I recommend a table, because those are my constraints right there. They're just written out nice and neat. What is the constraint for carbs? It is 30x plus 30y. Oh, not 30. Sorry, my bad. 10y is what? Greater than or equal to 170 or less than? What does it say under the table? Greater than or equal to 170. What is the protein's constraint? Someone read it out for me.
30x plus 30y.
30x plus 30y is what?
Less than or equal to
Less than or equal to 330. And vitamins?
100x plus 200y is greater than
Good.
1,445.
Good. What do I need to do? We haven't decided on the objective function yet. What is the objective function? What am I minimizing or maximizing? The cost. So objective function is going to be, how much does a power boost cost? 5x plus 3y. And you don't have any equals to, because you don't know what it equals. I'm just trying to make it as small as possible. So an objective function looks like this. Doesn't equal anything. Can I give you some time? Can you get that down, please? This area here. Go. I'll lock the door so the children can't in. Hopefully you see you could have got those constraints just from reading it, but the table makes it neat. If you do it in the table, what are my constraints? Read down, read down, read down. All right, next step. So what do? Decide on 2 variables, we did that. It was decided for us. Decide the objective function, we did that. We constructed the constraints using a table and we wrote them in general form. So now we're sketching the simplex. We're drawing this region here. So did you have some practice exercises that asked you to draw lines in general form? It's a facetious question because I know what the answer is because it's on YouTube. So if I wanted to draw the carbs constraint, what form is the carbs equation in? Slope, intercept, or general form?
General.
General. And so to draw a line in general form, what do I make y equal to?
0.
10 lots of nothing equals 170. So 30x equals 170. So x is going to be whatever 170 divided by 30 is, which is 5.67. To 2dp. Am I going to be able to draw the carbs line yet? If I know where it touches the x-axis? No, I need to know what the y-intercept is. So 30 lots of nothing plus 10y is equal to 170. Y is going to be 17. So I can draw that line now. Y is 17. X is not nice, but I'll draw it anyway. 5.67, so 5 2/3. Let's hope the iPad doesn't freak out and stop me from drawing a straight line. I'll be smart about it. I'll draw the line first, then adjust it after. Okay, that's the first constraint. That's carbs. According to the carbs constraint, whereabouts am I going to colour in? If it's greater than or equal to 170, what direction do I colour in? Down to the left or up to the right? Up to the right. So give yourself a little arrow here to say, if I'm colouring in, I'm going to be colouring upwards that way. What do I label this line as? This line is 30x plus 10y is 170. How many more constraints do I have? 2 more. So I'll do it in red. Proteins. 30x plus 30 lots of nothing equals 330. 330 divided by 30 is going to be 11. 30 lots of nothing plus 30y equals 330. What's y also going to be? 11. I can draw that line now. Dot. Dot. Duplicates. Is there a teacher in that class? All right, so that line that I just drew was 30x plus 30y. 30x plus 30y equals 330. According to the constraint, what direction am I going to draw? What direction am I going to colour in? Up to the right or down to the left? Down to the left. So give yourself a little arrow that I'm going to be colouring in below this line. Last constraint. Vitamins, or if you're English, vitamins. 100x plus 200 lots of nothing equals 1400. X is going to be 14, I believe. And yes, I will ask. You will always check my maths. And 200y equals 1400. Y should be equal to 7. So x 14, y 7. I'll stop after drawing and colouring in the Simplex so that you've got time to catch up. What line is this? 100x plus 200y equals 1400. And according to the constraint, which direction am I going to colour in? Up to the right. So draw a little arrow to remind yourself you're going to colour in there. What is the only shape here that follows all the colouring in arrows? Above this line, but below this diagonal line. this little triangle here. So I'm going to color that in. Don't worry, I'm going to stop soon. Just what does the step say? Sketch the simplex defined by the constraints. Label the axes of the graph, the constraint lines. We've labeled the lines. I've shaded the region, but I haven't done the vertices or labeled the graph, labeled the axes. So can you remind me, what did X represent? Which one, super boost or power boost or super health? Power boost is X. What was Y? And what was the last thing that was missing? I haven't labeled the vertices. So what is the coordinate of that little dot that I just placed? How far along the x-axis is it?
8.
How far up?
3.
Good. What's the location of this? 4, comma 5. And the last one here, 3, comma 8. I'll stop so you can get your own version of this simplex. For the video, I'm going to cut out all of the pause time so it's not going to take 3 hours to upload to YouTube. So like I've said, if you did all the exercises requested, is any of that stuff new? It's all stuff that you're asked to do. The only step next is the new bit. I'm going to scroll up again quickly and come back down. I just want to check what this step was. So step 5 was constructing the table with vertex. So I'll do that now. Vertex. Shh, boys. Objective function. What was the objective function for this situation? How much was the power boost? Do you remember? $5. 5 times by X plus. How much was the super health? 3Y. So this is that table thing. This is the only new thing that it should be. And hopefully I can show you, I can illustrate to you why the Simplex algorithm works. Right now, we have a bunch of solutions in this colored triangle. 3, 8 could work. 4, 5 could work. 8, 3 could work. But also, this dot here, 5, 6 could work. 5, 5 could work. I don't have time to check every solution. What did I tell you the Simplex algorithm says? The optimal solution is only going to happen at one of the corners. How many corners are there?
3.
So I only need to test 3. That's why this thing is sort of convenient. So I'll chuck a vertex here. It doesn't matter what order you do. I'm going to go 4, 5 at the top, 3, 8 next, 8, 3. And what do I want to do with those vertices? I plug them into the objective function because the objective function says $5 times by, what does this vertex say about the number of power boost cans I should buy? 4. So I go 5 times by 4 plus, how much were the super health cans? 3. And what does this solution say I should buy in terms of super health? 5 of them. So work that out. What's 5 times by 4? 20 plus 3 times by 5, 15. So that solution is $35. Can I decide right now that that's the best solution?
No.
because I haven't tested the other two yet. And I want the lowest. So I finish that off. 5 times by 3 plus 3 times by 8. 5 times 3, 15. Plus 8 times by 3, which is 24. 9. Is that 39?
Yeah, it is.
39. And then 5 times by 8 plus 3 times by 3. 5 times 8, I already know that this is more expensive. 5 times by 8, 40, but we do it anyway, 49. So for Josiah, what is the best option? He wants to meet his dietary requirements. His dietary requirements are always met within this triangle. But what's the best solution for him? Because I want to spend the least. Buying how many?
5 powers.
No?
4 power boost.
4 power boost, 5 super health. Okay, so you write that answer. Therefore, so we can answer our questions. Find the optimal combination. Therefore, A, optimal combo is 4 power boost, 5 super health. And how much did that cost? For $35. Now get that down quickly and then I'll answer B and then I'll be done. Told you to take longer. Yeah? You should try these Vomeros, they're hell comfy.
Sketches.
Yeah?
Just to show. Are they running shoes or styling shoes?
They were running shoes in the early 2000s, but they're... Because the style is dad shoes now. You probably don't want to look at the board because you missed one. Just watch the video up. All right, I'll quickly answer B so you can work on it. How much carbs, protein, and vitamins does Josiah get with the optimal combination? Where do I have some algebra that tells me how much carbs, protein, and vitamins is here? The table. Do I have a bunch of constraints? Right now, those constraints are telling me what I can't exceed or go less than, but I can also use these to work out how much that I actually get with this solution. So, what could I do? No, that's not going to work. How many power boosts did he buy in the optimal solution? 4. So the protein constraint, protein was 30 times by 4 power boost plus, what was the thing for super health for protein? Was it 10? No, for protein.
Yeah.
I think, oh no, so I should be doing, I'll do protein now because I stuffed it up. 30 lots of super health. 30 times 4 is 120, plus 30 times 5, 150. So you're going to get 270 grams of protein by doing this optimal solution. Is that less than or equal to 330, like we were saying?
Yes.
So it meets the requirement. Let's do carbs, which is what I was intending to do, but my mind... Carbs, 30 lots of the 4 cans, plus 10 lots of the 5 cans, 30 times 4, 120, plus 10 times 5, 50, 120 plus 50, 170 grams of carbs. Let's look at the constraint. What were you allowed with carbs? Greater than or equal to 170? Does he meet his requirement? That's the limit. That's the one that just touches. Okay? And then vitamins, 100 and 200. So vites, 100 lots of 4. What was it, 200? 200 lots of 5. 400 plus 1,000 equals 1,400 grams. Does that meet the requirement as well? Greater than or equal to 1,400? Whew, so, that's what that's about. I'll stop the video.